Okay, so on to question number 3. Okay, so given the balanced equation, calcium carbonate plus 2 HCl makes calcium chloride plus H2O liquid plus CO2 gas. Select all the statements that correctly describe how to calculate the mass of calcium carbonate that will react with 72.5 milliliters of a 0.25 mole per liter solution of HCl. The molar mass of calcium carbonate is 100.09 grams per mole. Select all that apply. Okay, so before I look at all the different options, I'm going to write down the equation, and I'll just solve for the mass of calcium carbonate, and then we can select all the different options that will apply. Okay, so the reaction is already balanced, so that saves us some time. And first I'm just going to write down everything that we know. So in the case of the calcium carbonate, we are looking for the mass in grams, and they give us the molar mass, which is equal to 100.09 grams per mole. And for HCl, they give us the volume, which is 72.5 milliliters, but I will convert it to liters just so that everything is in the same units, because the concentration of HCl is equal to 0.25 moles per liter. And yeah, so we just need to figure out the mass of calcium carbonate. So the first step is to find the moles of HCl that was added. Okay, so let's recall that the number of moles will be equal to the volume of the solution times the concentration. So 0.0725 liters times 0.25 moles per liter. This gives us 0.0181 moles of HCl. So this is moles consumed. Okay, so step 2 is to find the number of moles of calcium carbonate. So if we know how many moles of hydrochloric acid that was consumed, by multiplying it by the molar ratio, we can also find out the number of moles of calcium carbonate that reacted. So the molar ratio is 1 mole of calcium carbonate reacts with every 2 moles of HCl. So this will cancel out the HCl and give us the moles of calcium carbonate. So we pretty much have to divide the number by 2, and you end up with around 9.05 times 10 to the negative 3 moles of calcium carbonate reacts. And then next we're going to find the calcium carbonate mass. That reacted. So to do that, it's just going to be mass is equal to the number of moles times the molar mass. So it is 9.05 times 10 to the negative 3 moles. And the molar mass was given in the question, 100.09 grams per mole. Okay, so multiplying the two gives us a mass of 0.906 grams. So if we look at the options that they gave us in the question, A, 3.62 times 10 to the 2 moles reacts, so we know that that is not true. B, 0.906 grams of calcium carbonate will react. So we know that this option B is correct. I'm just going to put B a circle, but let's look at the other options. 0.29 moles of HCl is used in this reaction. So we know that that's not true because it is 0.0181. And lastly, the conversion factor 0.25 moles over 1 liter will be used as written in the calculation. So this isn't a conversion factor, it's pretty much just telling us the concentration. So the actual conversion factor, I believe, would just be the 1 mole calcium carbonate over 2 moles HCl. So that is also incorrect. Let's see what the junior tutor said. To answer this, we perform stoichiometric calculations. First, we get the moles of HCl from the volume and the concentration of HCl. Okay, so they multiplied the two, converted it to liters, and got 0.0181. Then we use the mole ratio between HCl and calcium carbonate. So they divided by 2 and got around the same 9.06 times 10 to the negative 3 moles. Lastly, we use a molar mass of calcium carbonate to get the grams that will react, and they also got 0.9 grams of calcium carbonate. Thus, based on the calculations, only D is correct. We can also make an argument for B since the values are very close to each other. Well, B is actually correct. I'm just going to say that the calculations are correct. Option B is indeed the correct answer. Option D is incorrect. It was pretty worded, kind of weird how they said the conversion factor will be used written in the calculation. Yeah, so 0. Actual conversion factor is 1 mole calcium carbonate over 2 moles of HCl. Yeah, but the actual calculations were correct. But I just added that little note.